Good evening, beautiful people out there. It's another beautiful evening here. So let's quickly look at another security level. And this time around, we are moving towards the higher level of security, which is Layer 3 security. We have been talking about Layer 2 securities. This time, let's look at Layer 3 security using access control list, shortened as ACL. Okay, so we'll start with the basic one, which is the standard ACL. Okay, as you might have known, there are two types of ACL: standard ACL and then extended ACL. The standard ACL is a basic one that filters traffic based on source IP address only, but the extended one is a bit more complicated, which can filter traffic based on source IP address, destination IP address, source port number, destination port number, and other values. Okay, so each of them have both named and numbered ACL. So the numbered and the named ACL are used to identify the ACL. Either you use value to identify them, such as ACL1, ACL2, or you use a name to identify it, such as ACF to block traffic of John, ACL to block traffic to 192.168, and a lot more. So without wasting time, we should go straight to the CLI to do the configuration. But before I do the ACL actual configuration, you have to plan your steps. What do you want to achieve with the ACL? How do you want it to be done? Who do you want to block? Who do you want to permit? So you have to make your plan down so that you will achieve the plan. So the plans are what I named as requirements here. These are the requirements I want to meet up with this ACL. Okay, so before I do that, there must be reachabilities between the devices in the network. So let me quickly do OSPF configuration to make sure every route is LAN, every route in the network is LAN between the two routers so that they can ping each other. So this is not part of the ACL configuration, but I just want to quickly do it, include it in this lab so that it will refresh your memory in the OSPF configuration. And also, I want to use a very short code. You might be interested in that short code to configure the OSPF. Okay, I want to use the interface OSPF configuration. So I will use interface range to apply OSPF configuration to all the active interfaces with just one line of command. Okay, so let me enter configuration enable mode with enable, then configuration mode with conft. So we have a G01, G02, G00. So I will use interface range and mark all these interfaces at once. Interface range G0/0/022. Okay. So to configure OSPF on an interface, you start with the IP OSPF 1. Okay, this is the ID of this OSPF, then followed by the area number, area 0. Okay, just like a magic, the OSPF have been configured on this router and is applied to all the three interfaces at once. So if I do the same thing on the second router, they will form neighborship relationship. Okay, so I'll go to the second router, CLI. Enable conft. Okay, interface range G0/0/022. IP OSPF 1, area 0. Okay, so the area number must match. Hit enter. So in just few seconds we will get a message that there is a neighborship relationship with router 1. Okay, so let me just wait. Okay, you can see that it's changed from loading to full state. So there is a OSPF relationship now. So let me show routing table VIP route. Yeah, it learn all the routes now through OSPF. Okay, so I can ping. I'm in router 2 right now, so I can ping any of this long side. Let me ping this server 20.20.20. Let me see .3. Ping 20.20.20.3. As you can see, I can reach it. So before I do the ACL configuration, let me prove that they can all ping each other before I also prove that the ACL is the one blocking them. So before the ACL, let them ping each other. Then after the ACL, they shouldn't ping each other. So the first requirement said that PC1 and PC6 should not reach 20.20 network. That is any device in that 20.20 network. After we configure ACL, they should not be able to ping any device in this 20.20 network. So meaning this is PC1, this is PC6. They shouldn't ping anybody in this network. So they shouldn't ping this PC3. They shouldn't ping this server 1. So before we do this here, let's first test them and be sure that they can ping them before we do the ACL configuration. So ping 20.20.20.2 the learning app. Okay, after the app, the ping is going now. Then .3. Okay, you can see the ping is going. I will not use much time to be doing the pinging, so let's go straight to the ACL configuration. So the instructions say that we should use standard number ACL on router 1 and then use standard name ACL on router 2. So the configuration is a bit different. Okay, so if you are using standard number ACL, we identify it with number. So this is router 1. So whatever ACL we configure here, we use a standard number. But one important thing that you would like to ask is, how do we know where to configure the ACL? We can configure all of them in this router 1. You can configure all of them in this router 2. But this standard ACL is a bit tricky. So there's one rule of thumb that says that you should apply the ACL to as close as to the destination. So if you are configuring the ACL, you should configure it on the router so close to the destination. This is because if you apply it to the router that is so close to the source, you may deny some packet that you are not meant to deny, because this one doesn't filter packet based on destination IP. Only the source IP. So even if there's any other network in that, any other device in the source range that you are denying, so it may be affecting the traffic going to another destination. So if you apply it early, so the best way is to apply to the so close to the destination. For example, there's a PC1 and PC6 should not reach 20.20 network. Therefore, if I'm configuring this ACL, this 20.20 network is in this subnet, is in this router, sorry, it's connected to this router. So I should apply to this G002, because G002 on this router is the closest to this 20.20 network. Okay, so if another one said this server 2 should not reach 4040 network. So 4040 network is connected to router 2, right? Yeah, so router 2J00 is the one having 4040 network. So if I want to configure any ACL that we meet up this requirement, I should configure it on this router 2, then apply to this G002 interface. So remember this rule, very important. Configure your ACL so close to the destination as much as possible. Okay, so the first one said PC1 and PC2 shouldn't reach 20.20 network. So the 20.20 network is on this router. So let's configure the ACL here. Alright, Let me exit out of here and go back to configuration mode again with Conf T. So to configure a standard numbered ACL, the command start with access list. Okay, so we say we should use a numbered one here. Access list 1. Oh, sorry, there's a dash between access and list. Dash list 1. Okay, so one more important thing here, the numbering matter. Okay, so there's a range of number used by standard numbered ACL. So you can use any number from 1 to 99 or 1300 to 1999. That is the range used by standard number ACL. So extended number ACL uses different ranges, so you shouldn't mix it up. Either any value from 1 to 99 or any value from 1300 to 1999. So let me use question mark. I think the next option is either to permit or deny. Okay, deny, permit. Okay, remark. So in this case, let's look at the requirement again. It says it shouldn't reach, that is, should not reach 2020. That means we are using deny command here. Okay, so deny. Okay, the source address of this PC1 is 10.10.10. This is PC1, so its address is 2. There's few new more option you can apply. That is wildcard mask of this IP address. This is a /32 address because it's an end host address. So you can specify wildcard mask of /32 as 0.0.0.0, right? Yeah, that's /32 wildcard mask. Okay, so 0.0.0.0. But if I don't specify anything like this, the device will automatically convert it to an end host IP address. We know that this is an end host, so it will use the default wildcard mask of that 0.0.0. Or you can still use the option host before the IP address, right? You can use host like this, host, then followed by the 10.10.10.2. Okay, so if I hit enter like this, the device will recognize it, but I can still specify the wildcard mask of 0.0.0.0. Okay, I think it's the wildcard mask. Let me use question mark. Okay, if I specify host, I don't need to use wildcard mask again, so let me just hit enter. All right. The second one is this PC6. Just configuring the access list. We are making access list entries right now. Okay, so it's called ACE, access list entry. I just make first entry, which is this one. So the entries are processed from top to bottom. If the interface receive any traffic, that is the interface we will apply it to. It will first of all check this first entry I have created. Then if I create another entry, which is the one I will just do for PC6 now, for this PC6, then the device will also check the second entry only if there is no matching entry in the first entry. That is, if there is no action taken. If this one doesn't meet the requirement, then it will check the second entry. But if it meets the requirement and it denied any packet from this host 10.10.10.2, it will not continue with the checking of the list. It will just stop its action. But if we check the list and there's no matching entry, no any action was taken, then it will proceed to the next entry to check more. Okay, so we will configure the second entry now, which is for PC6. Okay, so access dash list 1. So they are all the same ACL. still using this access list 1. So because we apply it to one interface, they are still the same ACL but different entries this time. So deny 10.10.10. That's PC6 is .4, right? .4. So this the IP address are assigned to PC6.4. Okay, so let me go with the wildcard marks option. I didn't specify host this time. I think I should, I'm allowed to use wildcard marks this time. So 0.0.0.0. Okay, so hit enter. Alright, okay, so we are done with this entry, but before you close it, there's one more important rule here: explicit deny. Okay, so if you leave it this way, any other packet received on that interface will be denied after checking these two entries. So it is called explicit deny. So you have to permit every other traffic. Okay, if you don't block all traffics. Okay, so the process is still the same. Access list 1 permit any source. That this any means any source. Alright, okay, so this is all for this access list, but let me add remarks. Since we are naming it with number, it will be difficult to know which access list is this one. So it's better we add a remark to it too, so that when we check our running config or when we check our access list, we know for which customer is this. Okay, so let's go with access list remark. So the command is remark. Let me use question mark. One access list 1 remark question mark. Okay, so I want to name it to deny PC 2 and PC 6. Alright, so that's all here, but one more thing: to complete this access list, you have to apply it to an interface. You only configure the access list so far, but you have not applied it to an interface, so action will not be taken. So that's more important. And you remember the rule: the access list should be applied to the interface that is so close to the destination, that is the place you are controlling access to. So it should be applied to the interface that is connected to that network. Okay, so we are denying access to 2020 network. So this is 2020 network, and 2020 network is connected to G0/0/2. So we should apply it to that interface. Okay, so let me enter interface configuration mode with interface G0/0/2. Okay, so the command to apply to the interface is a bit different. It starts with IP access -group. Okay, group is not access list this time around, it's access group. So followed by the access list name or number. Okay, so we have 1. Okay, so it's 1. Okay, you apply it outbound. So it's best practice you apply to outbound to the outgoing interface. Okay, so out. There's any IP packet exiting this G00 will be checked if it meets the requirement. Okay, let me end show access list to verify your configuration. Alright, so this is the one we configure. Access list 1, deny host. Okay, you see the second one I didn't specify host, but the device configured it converted to the host. Okay, so let's verify this ping let's verify this configuration with a ping to this 2020 network. We can ping either PC3 or server 1. Okay, if the ping will go through from any of these PC2. Okay, dot 2, right? Dot 2, who is choosing dot 2? Okay, PC1. We want to check if PC1 and PC6 will still reach this 2020 network to verify our configuration. Okay, so to command prompt ping 20.20.20.2. okay, destination host unreachable. Okay, destination unreachable. But if I ping from this PC2, because we didn't deny PC2, it should be reaching that same network. That is 20.20.20.2. Okay, go to desktop, command prompt, ping 20.20.20.2. okay, so as you can see, this PC2 is reaching it, so PC3 should fail also. PC6 should fail also because we denied it source IP. Okay, ping 20.20.20.1. let me pick .1 this time. .1 is the router interface. Okay, let me pick .2. okay, so .1 is within the router, so it's not blocking that ping. So .2 is exiting the router. So .1 was not exiting the interface, that's why it was going through, but .2 is exiting the interface before you can reach the PC. Okay, .3 is the server. Let me try .3. Unreachable. Okay, so the first requirement is met. Okay, so we continue with the other configuration, but before I do that, let me check our access list again. The counter of deny must have increased. Okay, so as you can see, it denied 4 packets, and then from this host, which is .2, which is the PC, and then it denied 8 packets from this PC6 because I first pinged the PC3 and the server. Alright, let's look at requirement 2. Requirement 2, only PC2 should reach 3030 network. Where is 3030 network? 3030 network is located on router 2. Okay, so we will configure this ACL on this router 2. Okay, so in this case, it say only PC2 should reach here, should be able to reach here. Every other one should be denied. So maybe we will apply the implicit deny at the end of after permitting PC2. Okay, who is PC2? This is PC2. Okay, so its IP address is 10.10.10.3. Okay, so we'll go to this ACLI. Remember the instruction here. It says we should use standard name ACL on this other router. Okay, so enable config. So to configure standard name ACL, you have to first of all enter the ACL configuration mode. Okay, so the starting line is a bit different here. The other one, you type everything in one line, but this one you have to enter the ACL configuration mode, then you start defining your ACE, which is access control entries. Okay, so this one start with IP. Okay, the other one starts straight with access list, but this one start with IP access dash list, then followed by standard. Okay, because we want to specify whether it's a standard ACL or an extended ACL. Assuming we are using extended, we would have followed by extended, but starting with standard, show that it's a standard name ACL. So we're using question mark to show what's the next option, but I believe the next option is the name of the ACL where you are going to use words. Okay, standard IP access list, and where's there is access list name. Okay, so we are going to use the name to permit PC2. Okay, PC2 to permit PC2. Okay, let me use question mark, and that's all here. So as you can see, in this bracket I'm in configuration. That is ACL configuration mode. Now initially in the bracket you are seeing config, meaning global configuration mode, but here you are seeing standard and ACL, meaning I'm in ACL configuration mode now. So I'm going to define my ACE, which is access control entries. So the entries here is to permit 10.10.10.3. okay, and then after that I deny every other packet. Okay, so you can start with defining the sequence. Okay, so start with defining the sequence, but if you don't use the sequence, the system will automatically select the interval of 10, the next entry will be 20, after 20, 30, but I think, let me use question mark if the sequence option will be available here. Okay, yeah, as you can see, 1 to so much value here, but the sequence number. So let me just use let me start my sequence with 20. Okay, then question mark. Okay, I want to permit. Okay, permit 10.10.10.3. okay, that is PC2 IP address. Sorry, 3. Okay, so white card mask of this. If I don't put the white card mask, I think it will just recognize that it is a host IP address. Okay, so let me ignore it and see what's gonna happen. All right, then the other one is to deny. Okay, after 20 I put 40, then denied any. Okay, that is after you permit only this PC, deny every other source address. Okay, so let me use question mark and see, and there's then the next option is to apply to the appropriate interface. Okay, so let's check the interface this 3030 network is connected to. So the 3030 network is connected to G001. Okay, so remember the name of the ACL because you type in the name when you want to apply to the interface. So let me go back again and see what name do we use to permit PC2, right? Okay, so let me exit out of here, exit, enter interface configuration mode with interface G0/0/1 IP access -group. So to apply to the interface, the command still remain the same, just that you will change it from number to name of the ACL here. Okay, IP access -group to as you can see, this PC is being blocked from reaching this 3030 network. Only PC2 should be reaching there. So let me confirm that again. 3030 network, 3030.3 is going. 3030.2 should be going to Okay, so let me also prove that this one will not be going through. Okay, so initially they were all going, but after applying the ACL, it will stop going. It will not be reachable. Okay, ping 30.30.2. So you can see host destination host now reachable. .3 still not reachable. Okay, so we have meet 2 requirements out of 4, right? So let's quickly go through the third one. 4040 network should not reach 10.10.10. Okay, 4040 network. Where is 4040 network? Okay, that is this PC4 should not reach 10.10.10. Okay, so that means we have to configure another one here on this router 1. We earlier configured one that was applied to another interface, which is this one, I guess, yeah, which was applied to this G002. So now we are configuring another one that will be applied to this G001. Okay, so let's go back to the CLI. Dash list 2. The first one was list 1. Okay, so we use 1 to name the first one, to number the first one. So this time we are using 2. Okay, so I want to, what was the option? Say 4040 network should not reach, so it should not reach, meaning we are denying 40.40.40.0. So this is a network address, so we have to specify the wildcard mask of /24 here. So wildcard mask of /24 is 0.0.0.255. okay, so
It's young Fred, the dangerous producer.
list 2. So we have not violated or try to ping, so there's no any statistic on this access list 2 yet. So I'm going to ping from that source now, which is 4040 network. Only this PC4 is on this 4040 network. I will try to piece any of this PC 10.10.10.2.3.4. okay, so it will try to ping. Alright, ping 10.10.10.2. okay, destination host unreachable. .3 is the ACL that is blocking it. Of course, if you check the ACL again, you will see that the statistics has increased. Okay, .4. Alright, so they are all unreachable. I'm going to check the access list again. Hit up okay, do show list. Okay, you can see it has denied 12 packets from that PC. Alright, so we are done with that. Okay, we have to do the last one now, which is server 2. Here is the server 2 should not reach 4040 network. Okay, want to prevent server 2 from reaching this PC. Okay, every other packet should be reaching here. Alright, so let's do that right now. So we have to use access our standard access list name. So standard name ACL on this router here. So we are creating another standard name ACL. The first one was to permit PC2. This one we deny server 2. Okay.
Is young Fred the dangerous producer? Is young Fred the dangerous producer?
Okay. Ping. This is server 2. Ping 40.40.40.2. Destination unreachable. Okay. The SSL doing its work, is blocking it. So this PC5 that is in the same subnet with this server 2 should reach that same 40.40.40.2. Let me justify that. Ping 40.40.40.2. I think it's learning our app because this is the first time I'm pinging that. So after app it should go through. It's still failing. Maybe something is wrong. Let me check. This PC5 supposed to have access to this 4040 network, but yet it can't ping this PC7 because earliest access list we configured has blocked this 4040 network from reaching 3030 network. In this list, the only PC2, which is this one, should reach 3030 network, meaning every other IP packet will be blocked. So if this PC5 ping, this PC7 need to reply. Therefore, if you try to reply, the G00 outbound ACL will also block its own traffic, so it cannot reply this PC. Okay, but if I check the access list, you see that this PC5 packet was permitted by the access list applied to this G002 interface, but because its own outgoing from this PC7 was blocked, it cannot reply this PC7. Okay, so let me show the access list again. As you can see, this access list to permit, this particular one, to deny server 2, which hosts this PC5, is the one taking action right now. So it denied 4 entries, which is the ping from the server, which is server 2, and then it permits 24 packets. But yet that packet cannot, that PC cannot get a reply because there's still another ACL that is blocking this PC's reply to the PC5. So let me check the stuff again. So this first one, this deny, is the one blocking the reply from the PC7. That's why it's not reaching it. Okay, so the PC5 cannot reach PC7 despite its packet not denied, but another ACL is taking action against it. So I have been pinging it trying to find out why it was denied initially. So that's when I realized there's another ACL blocking its response. Okay, so that's how the ACL works. That's why you have to calculate well, plan it very well, not to apply to the wrong interface. If not, it may block another packet you not even intended to apply. So the best one will be the extended ACL, which also specify the destination. So if source IP is specified, then it will also filter it based on the destination. Alright, it will not just filter only source packet, it will also consider the destination. If the destination is not the same, it will not block it unless they specify destination. Okay, so that's all for today. If you like this video, don't forget to subscribe to my channel, share with friends, like, comment. Don't forget to turn on the notification bell so that you notify whenever I post. Have a beautiful day.